On the face of it, NASA's newest probe sounds incredible. Known as Dragonfly, it is a dual-rotor quadcopter. It's roughly the size of a compact car. It's completely autonomous, it's nuclear powered, and it will hover above the surface of Saturn's moon Titan. But Elizabeth Turtle, the mission's principal investigator at the Johns Hopkins Applied Physics Laboratory, insists that this is actually a pretty tame space probe. A nuclear power is harder to come by, but the team plans to use the same kind of system that runs NASA's Curiosity rovers on Mars. NASA reached that conclusion when, after a lot of careful study, it gave Dragonfly the green light earlier this summer. This revolutionary mission would have been unthinkable just a few short years ago. NASA's administrator Jim Bryanson said when the roughly $1 billion project was selected in June, "A great nation does great things." For Shannon McKenzie, postdoc on the mission, there is no destination that could be greater than a Titan. The largest moon of Saturn, it has dunes, mountains, gullies, and even rivers and lakes, though it's on Titan. It is so cold, the lakes are filled with liquid methane and not water. And she says it is this a complete package. It's this really unique place in the solar system where all of these different processes are coming together in a very Earth-like way. Turtle says these factors are part of what made Titan a target. It also appears that the surface is covered in organic molecules. The climate is probably too harsh for those molecules to make a shift into life, but Turtle thinks Titan could provide clues after how the building blocks of life started on the Earth. Titan has one more feature that was nothing. Although its mainly nitrogen atmosphere is denser than Earth's, its gravity is far lower. That makes it a perfect place to take the skies. The conditions on Titan make it easier to fly there than on Earth, says Peter Bedini, the Dragonfly project manager. A drone is actually a much better way to explore. Dragonfly will launch from Earth in 2026 and arrive on Titan in 2034. After it enters the atmosphere, it will literally drop from the back of a capsule that brought it and fly down to a set of sandy dunes on the surface. From there, it will make a series of hops over 2 years, sampling the ground and sending back data and photos. Adam is confident the Dragonfly will be able to safely buzz across Titan's terrain, because it can take nearly 2 hours for a signal to reach Titan from Earth. It will have to fly autonomously. We make joke if we hit a tree, then we win, because we found a tree on Titan. Whereas motors and software can also be used or relatively easily adapted for the Dragonfly. There's one thing he can't bring, however. We don't actually have a map. There's no GPS. He says the drone will navigate by continuously photographing the landscape, creating its own map as it goes. But now, Dragonfly team is still working with the drones here on planet Earth to figure out how to build systems and software the probe will eventually need.